All right, guys, welcome back. So, the previous videos went over your big four equation number one, and then also we went over a free fall example question just to give you more practice and a better understanding of the use of these equations. So, quick recap. In kinematics, when we're using the big four equations, we're looking at objects that have a constant acceleration. That means our speed is changing at the same amount, the same rate for each time period. Another word you may see is uniform. So imagine if you're in school and everybody is wearing a uniform, that means we all look the same. So that's why we use that in physics to describe acceleration being the same. So we're looking at constant or uniform acceleration. We have four equations that we look at. Now we're going to look at equation two. We're still going to implement the same strategies by listing the five variables that we see in those four equations, and I will show you how we're going to solve problems that uses that equation. Okay? So, first problem, you don't have to write the problem, but it will help you if you'll follow along and place the information that's in the problem on the side to its appropriate variable. Okay? We have an airplane that accelerates down the runway at 3.20 meters per second squared for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before it takes off, before it lifts off. So, as stated in the previous videos, we're going to work backwards. Let's look at what the question is asking us to solve. The problem says, determine the distance. So that means over here, I put a question mark for distance. We keep going back. We see that the plane lifts off the ground. We don't care what happens with the plane when it comes off the ground. We're only talking about the takeoff. So it takes, what, 32.8 seconds for that plane to take off. Well, when we see seconds, we know that is time. Okay? Next piece of information that we have is 3.20 meters per second squared. Anytime you see meters per second squared, that is the units, the standard units that we see for acceleration. Meters slash seconds to the second power. I'm going to put 3.20 for our acceleration. Okay? So now if you look on the side, all we have left is VI and VF. Well, since I'm telling you which equation we're doing, you know that we're not going to use VF. But at the same time, if you look at the problem, we're not looking at a final velocity, because the final velocity would be the speed that the plane has as soon as it takes off. However, the plane, at the beginning of the trip, the plane would not move. So we're coming from a position of not moving the plane, and now we're starting to take off. So initially, or in the beginning, our plane has a speed of 0 meters per second. That's the beginning speed. How do we know? Because it's not moving at the beginning of the runway, then it starts accelerating. Okay? So a lot of times in these problems, they won't tell you specifically what your initial velocity is, but you will have to use common sense. We will just have to just think about what we are seeing when we're reading the problem. If the plane is taking off, it has to start from a position that's not moving. And that's how we got zero. And in the last video, we're used to seeing zero because we're dropping the object and we know there's no speed before we release the object. Now we have an object that's on the flat surface and it's starting to go up the runway. So the beginning speed is zero. Okay. So now we see VF is completely left untouched. So I'm going to cross it out. And if you had a cheat sheet of all four equations, which you will, you'll see I have a time, I have an acceleration, I have my starting velocity, and I need to figure out distance. Well, equation number 2 is the only equation that has all four variables. Therefore, that's the equation that we will use. So I'm just going to rewrite the equation as we see it. Now we're just going to take our data, our information, and we're going to substitute it in the equation. B, we don't know. BI is 0 times my time of 32.8 plus 1/2. Acceleration is 3.20 times that same time number to the second power. Now me, I love shortcuts. I don't like to do a lot of hard work, so we can just take care of everything we need in one straight sentence, one straight shot. So anything times 0 is what? Good job. I hope you said it out loud. Now, this last part, I'm going to take my phone calculator. I'm going to have 0.5, which is the same thing as 1/2, times 3.20 times 32.8 to the second power, and then I close my parentheses. So I'm not sure how your phone calculator may look, but this is how mine's look. 0.5, which is 1/2, times 3.20 times 32.8 raised to the second power. You should get that answer. 1,721. I'm going to round it to 2 decimal places. And if you look at our units, hey, we have a meters in our acceleration units. So that means our distance needs to be in meters, which it is. Okay?